Let's take this challenging problem on sequence and series, and the question says, as you see that the decimal digits are written to form an infinite sequence, or like all the decimal digits starting from, like, all the natural numbers are written one by one, 1 2 3 4 5 6 7 8 9 10 11 12, like that, and side by side. And we are defining a function fn equal to m, and it's going to happen if the 10 to the power nth digit forms part of an m digit number. Like one example is shown for better understanding in this case. Like f1 is going to be 2, because f1 means we are going for the 10th digit, 10 to the power 1th digit, and 10 to the power 1th digit from the beginning will be 1. Okay, and that 1 is a part of a 2-digit number 10, so f1 must be 2. Similarly, f2 means we are looking for the 10 to the power 2th digit, that is 100th digit, and that 100 digit, if we calculate, it will be part of 55, and since 55 is a 2-digit number, so it will be 2. So we need to find out the challenging value of f of 1987. So basically we need to find out the 10 to the power 1987th digit. Okay, so we need to find out 10 to the power 1987th digit from the beginning. Okay, so here if you see, there is a pattern out there, like starting from 1 to 9, these are single digit number, so we can say that there are 9 one-digit number, and starting from 10 up to 99, so this will be 2-digit number. So from 10 to 99, total 90 numbers are there which are 2-digit. Then starting from 100 up to 999, that is 900 numbers will be of 3-digit number. So we are getting a pattern out there, like 9 numbers of 1 digit, 90 numbers of 2 digit, 900 numbers of 3 digit. So in this way, if we try to find out the total number of digit that will appear up to m digit number, so total number of digit up to an m digit number, so we can plan up to an m digit number. Total number of digits from the beginning is going to be, there are 9 one-digit number, there are 90 two-digit numbers, 90 into 2, plus there are 900 3-digit number, 900 into 3. So in this way it is going to continue. For the m digit number, it is definitely going to be 9 into 10 to the power m minus 1 into m, because from the pattern we can see that for 1-digit number it is 9, for 2-digit number there are 90 such number, for 3-digit number there are 900 such number. So for m digit number there will be 9 into 10 to the power m minus 1 number of digits. So up to the last m digit number, total number of digit, if we want to calculate, it is going to be 9 into 1 plus 2 into 10 plus 3 into 10 square. So in this way the series will continue up to m into 10 to the power m minus 1. Now this is forming a series which is called an AGP series, that is arithmetico-geometric progression, because you can see that 1 2 3 4 like that up to m will form an AP series. So the first component is an AP, and the other component, like 10 10 square 10 cube up to 10 to the power m minus 1, that is a GP. So this is combination of arithmetic and geometric progression, which is called AGP series. And here we can quickly discuss how to find out the sum of an AGP series. So we can take this particular sum to be equal to, suppose, s. So let's try to quickly find out what is the value of s. So s is nothing but 1 plus 2 into 10 plus 3 into 10 square, in this way up to m into 10 to the power m minus 1. And to find out the s, we follow a process, that is we take out the common ratio of the GP, like it is getting multiplied with 10, It's like 10, 10 square, 10 cube, like that. So we'll multiply the whole series by that common ratio 10, so 10s, and we'll be shifting one place to the right, like we'll be multiplying this 1 with 10 and we'll be writing here. Then we'll be multiplying 2 into 10 with 10 and we'll be writing here. So we'll be shifting one place to the right. So below m minus 1 will come, and this will be shifted to right, and it will be m into 10 to the power m. Now if we subtract the two series, so if you subtract the two series, then we'll be getting minus 9s equal to 1 plus 10 square plus 10 cube. Okay, so we are getting a pure GP series up to 10 to the power m minus 1 minus m into 10 to the power m. Now since starting from 1 up to 10 to the power m minus 1, this is a GP series, so we can apply the formula of GP out there. So it's going to be 10 to the power m minus 1 by 10 minus 1 minus m into 10 to the power m. Now we can see that we need to basically find out the value of 9 into s, and here we have got the value of minus 9s. So we can say that the number of digits up to the m digit number, so number of digits up to the m digit number is going to be just negative of this number, that is 9s. So we can write it as m into 10 to the power m minus 10 to the power m minus 1 divided by 9. So it's going to be m minus 1 by 9 into 10 to the power m plus 1 by 9. So this is the total number of digits starting from the very first digit up to the last m digit number. Okay, so this is the total number of digits up to the last m digit number. Now we need to find out the 10 to the power 1987th digit. Okay, let us go back to the problem. We need to find out 10 to the power 1987th digit in this particular infinite sequence. So for 10 to the power 1987th digit, we need to see that what can be the value of m for which this series is close to 10 to the power 1987. So that is the point. Now we need to apply heat and trial process basically. That is like if we need to reach 10 to the power 1987, we need to plan that for what value of m we need to choose so that we will be reaching very close to 10 to the power 1987. So by heat and trial, if I proceed, then we can see that for m equal to, like if I take a value that is 1983, like if I take m equal to 1983, then the total number of digit is coming out to be 1983 minus 1 by 9 into 10 to the power 1983 plus a very small quantity, that is 1 by 9. Now we can see that 1983 minus 1 by 9, this is definitely less than 10 cube, 10 to the power 4. So we can definitely say that this number is definitely going to be less than 10 to the power 1987. That's for sure, because 1983 minus 1 by 9, this is going to be a 4-digit number, so this has to be less than 10 to the power 4, and this is 10 to the power 1983, and 1 by 9 will not make much difference. So 10 to the power 4 into 10 to the power 1983, that is 10 to the power 1987. So this whole quantity for m equal to 1983 has to be less than 10 to the power 1987. And if I go for the next value of m, that is m equal to 1984, for m equal to 1984, this particular total number of digit is coming out to be 1984 minus 1 by 9 into 10 to the power 1984 plus 1 by 9. Okay, now we can see that this particular quantity is going to be a 4-digit number, so this is definitely greater than 10 cube into 10 to the power 1984. So this is definitely going to be more than 10 to the power 1987. Okay, so we can say that if I consider 1984 digit numbers, If we consider 1984 digit numbers, then the total number of digits starting from the beginning is going to be more than 1987. So we can say safely that 10 to the power 1987th digit is definitely going to be part of a 1984 digit number. So our answer is going to be f of 1987 is equal to 1984.